16代目のクラウン、日本の歴史に重ね合わせれば、それは明治維新です。ご覧ください。新しい時代の幕開けです。
Toyota's hydrogen engine might just change the game forever. Toyota is sparking a whole new revolution in the auto world, one that's shaking up the electric vehicle industry in a big way. And let's just say, EVs might never be the same again. According to Toyota's CEO, the company has developed an engine that could potentially destroy the entire EV industry. We're talking about an engine that is completely different from the current EV powertrains. But does this mean we're about to witness one of the greatest shifts in the automotive landscape? And if you're excited about the future like we are, make sure to hit that subscribe button so you don't miss out on more groundbreaking discoveries and mysteries about the future of technology. Let's dig in and see. Before we jump into what Toyota's CEO recently revealed, let's rewind a bit and see how we got here. In the fast-moving world of cars, Toyota has made one of the boldest moves yet, and it's got the whole EV industry buzzing with excitement and curiosity. To really grasp how big this is, picture a breakthrough engine so revolutionary it leaves even die-hard car fans on YouTube completely stunned and amped up. This isn't just another upgrade, this engine is a serious game changer. Not too long ago, Toyota announced the creation of a new hydrogen combustion engine. But this isn't your average hydrogen setup. While other automakers have gone all in on electric, Toyota decided to go down a completely different road. They've developed a whole new kind of technology that's unlike anything else out there right now. Just like the name suggests, this hydrogen combustion engine runs on hydrogen fuel. But here's the kicker. Unlike traditional engines that pump out carbon dioxide, this one only releases water vapor from the exhaust. This is how Toyota is stepping up to lower the planet's carbon footprint in a powerful new way. Let's dive deeper into how this tech really works. As we've already touched on, Toyota is taking a different path when it comes to cutting carbon emissions. Instead of jumping on the all-electric bandwagon, they've gone with hydrogen combustion. Hydrogen is actually one of the most common elements in the entire universe. In fact, it holds the highest specific energy density of any non-nuclear energy source, and when it's used as fuel, hydrogen is clean, non-toxic, and the only thing it leaves behind is water. Hydrogen can be made in different ways, stored for as long as you want, and easily transported. Believe it or not, millions of tons of hydrogen are already being produced and used every year. It's currently powering buildings, electric vehicles, forklifts, ships, and even trains. That's right, not everything needs to run on gasoline. Toyota's hydrogen combustion engine works with a fuel cell that turns hydrogen into electricity. Take the Toyota Corolla Cross H2 concept car as an example. It's powered by a 1.6-liter turbocharged 3-cylinder engine that runs completely on hydrogen. But how did Toyota actually pull this off? Well, this is where things start to change in a big way. This breakthrough engine tech could seriously shake up the EV world. To safely store the super flammable hydrogen, Toyota equips the car with thick, armored fuel tanks, built using the same approach as their FCEV, the Mirai. But don't worry, these tanks aren't giant. The Corolla Cross H2 concept needs just 5 kilograms of hydrogen to travel roughly 300 miles. And emissions? The engine produces just 50 liters of water. And let's be real, water's a lot better for the environment than carbon dioxide. To push this even further, Toyota joined forces with Yamaha Motor to create a hydrogen-powered V8 engine. It cranks out 455 horsepower and 398 pound-feet of torque. They even gave it an 8-to-1 top-mounted exhaust manifold that creates a sharp, high-pitched sound, something totally unique. When you compare Toyota's hydrogen combustion engine to typical EVs, a few big advantages pop out. The top one, way longer range and refueling time that's lightning fast, more like a race car pit stop than charging an EV. Plus, it reduces our need for limited resources like lithium and nickel, which are key for making big EV batteries. Yes, the vehicle still uses a battery to store energy, but it's way smaller than what you'd find in most EVs. As of late 2023, the Corolla Cross H2 concept was out in the real world, being tested in winter conditions up in northern Japan. And so far, the early feedback, super promising. In short, Toyota's hydrogen combustion engine could totally change the game for the auto industry. It's one of the cleanest engines we've ever seen. Its only byproduct is water. Add in a longer driving range, quicker refueling, and less reliance on rare materials, and it's easy to understand why this innovation is catching people's attention. If this hydrogen-powered engine takes off, Japan plans to have 200,000 fuel cell vehicles on the roads by 2025 and up to 800,000 by 2030. To make that happen, they'll need to roll out a lot more hydrogen refueling stations across the country. So, we've seen how different the hydrogen combustion engine really is. But what are the upsides and downsides? Let's start with the good stuff. The first and most obvious advantage is that it is a very eco-friendly engine. Given that it uses hydrogen as its fuel source, it doesn't produce harmful byproducts, just as we've already discussed. Furthermore, hydrogen is a clean fuel on its own, especially when compared to traditional gasoline engines. The second advantage is that this engine has a very effective cooling system. The innovative water cooling system addresses one of the major challenges of engines: high operating temperatures. This system, which comes with hydrogen combustion engines, potentially enhances engine performance and longevity. This means that problems like overheating would become very rare if the engine were to be used in the real world. And as we all know, that's something that would really benefit a lot of drivers. The third commonly cited advantage is that this engine uses completely familiar technology. Since it mainly operates on a system similar to traditional internal combustion engines, it's easier to integrate into existing automotive design and manufacturing processes. This is a major benefit for Toyota, as they can simply modify some of their other cars to accommodate this engine. Clearly, the hydrogen combustion engine makes a strong case when it comes to its advantages. However, nothing is without its disadvantages. The very first disadvantage is related to the production and infrastructure of hydrogen. While the engine itself is eco-friendly, many people don't realize that this depends entirely on how the hydrogen is produced. At the moment, even though hydrogen production is becoming more widespread, it's not always sustainable. Therefore, if these cars are to be produced in large quantities, the automaker must first address this issue. As abundant as hydrogen might seem, there's still the issue of fueling infrastructure. Hydrogen cars are not yet common, and there are far fewer hydrogen fueling stations compared to gasoline and electric charging stations. Another issue with hydrogen combustion engines is their complexity and cost. Even though the engine architecture is similar to traditional engines, it includes a dual water injection system. Combine that with the need for precise control by the ECU, and the entire system becomes more complex. Increased complexity naturally leads to higher manufacturing costs for the automaker. For the owner, maintenance is also more expensive, mainly because the parts are not as widely available. Let's say Toyota does achieve large-scale production of this engine. They would still face the challenge of market readiness. As of now, the production-ready version of this design is still under development and testing. Even if it's approved for market release, Toyota would definitely need more time before the car becomes commercially available. By developing this hydrogen combustion engine, Toyota has shown its commitment to exploring multiple solutions for sustainable transportation. In addition to their electric and hybrid powertrains, this engine represents a completely different approach. It reflects Toyota's interest in diversifying its sustainable vehicle options. Now, we've often talked about the hydrogen combustion engine, highlighting how promising it is and how it might even disrupt the EV industry. But how different is it from the traditional internal combustion engine? What are the technical aspects that make it stand out? To answer these questions, let's focus on one of Toyota's standout achievements in this field: the 1.6-liter, 3-cylinder turbo hydrogen engine. For those wondering why we're looking at this specific model, it's because it's one of Toyota's most successful hydrogen engines. It's currently being used in the Corolla Cross hydrogen prototype, and it's performing incredibly well. This engine perfectly blends traditional design with pioneering technology, and it does it well. However, it is completely different from a conventional internal combustion engine. The 1.6-liter 3-cylinder turbo engine is a marvel of engineering. It's based on the same platform as the engine found in the GR Yaris, which, as we know, is celebrated for its performance and agility. To make the engine compatible with hydrogen, Toyota had to implement several modifications. After these changes, many people had questions, chief among them: how did Toyota manage to maintain the engine's performance while switching to a completely different fuel source? The answer lies in the hydrogen combustion process. Compared to gasoline, hydrogen requires entirely different handling and combustion techniques. Keeping this in mind, the engine uses a high-pressure hydrogen direct injection system. This is a significant departure from traditional fuel injection systems. With this system, the engine can precisely control the delivery of hydrogen into the combustion chamber, greatly optimizing performance and efficiency. But even with this innovation, how is the engine's overall performance impacted? Surprisingly, this hydrogen engine performs exceptionally well. The 1.6-liter engine can generate enough power and torque to compete with its gasoline counterparts. This is largely thanks to the turbocharger, which plays a crucial role in boosting performance and delivering the high output needed for a performance vehicle. However, some concerns remain, particularly about whether turbocharging is the best way to handle hydrogen's unique properties. The main concern is that hydrogen has a relatively lower energy density compared to gasoline. Because of this, the engine requires a larger volume of hydrogen to produce the same amount of energy. Toyota's engineers have tackled this challenge head-on. They've made sure that the turbocharger and other engine components are optimized specifically to handle hydrogen fuel. One of the key things that makes this engine stand out even more is how efficient it is. It turns out, hydrogen combustion engines are much more efficient than traditional ones. This difference becomes even more obvious when the engine is under heavy load. Because of this, fuel economy improves a lot, and there's a strong positive impact on the environment. With this bump in efficiency, the engine uses fuel more wisely, and even more importantly, emissions drop by a huge margin. In fact, the only thing it gives off during the whole combustion process is water vapor. That means emissions are almost zero. And as we mentioned before, that makes it one of the greenest options available today. Reaching near zero emissions with the hydrogen engine is a big deal for Toyota, especially since it ties directly into their goal of achieving carbon neutrality. As Toyota pushes toward a future with no carbon footprint, they aren't sticking to just one path. Instead of relying on a single solution, they're using a wide mix of hydrogen and electric tech to make it happen. Given Toyota's tech strengths, they could easily take a single-route strategy. But then, why are they going for a broader, more multi-layered game plan to hit carbon neutrality? To get that, we first need to look at how committed Toyota is to hydrogen technology. So you might be wondering, why pick hydrogen in the first place? The answer is simple. It has huge potential as a clean energy source. Whether used in fuel cells or combustion engines, hydrogen only emits water vapor. That makes it one of the cleanest alternatives to fossil fuels we've got. But Toyota isn't just using hydrogen tech for regular passenger cars. They've also applied it to commercial vehicles and even public transport. Still, can hydrogen alone take us all the way to carbon neutrality? Let's just say Toyota has thought this through. They know the risks of putting all their eggs in one basket. That's why they've also gone big on electric vehicle technology. A major piece of their plan includes developing battery electric vehicles, BEVs. But their approach is different from many other car makers, especially those going all in on EVs alone. Toyota's strategy takes into account the real-world hurdles that come with EVs. Things like short driving range, long charging times, and the environmental cost of making and scrapping batteries. To work around that, Toyota has rolled out different powertrain choices, the big ones being hydrogen fuel cell vehicles, FCEVs, plug-in hybrid electric vehicles, PHEVs, and BEVs. By offering these options, Toyota can meet the needs of a wider variety of drivers and driving styles. This whole mix-and-match method supports the bigger mission of carbon neutrality, and they've tackled it in multiple smart ways. One of their biggest insights is this: different parts of the world run on different energy sources, have unique infrastructure setups, and follow their own environmental rules. So trying to fix the global carbon problem with just one solution might not work everywhere. Take regions already powered by renewable energy. In those places, BEVs make the most sense. But in areas where hydrogen is created using green sources, FCEVs, and hydrogen internal combustion engines, HICES, might be the smarter pick. Even so, Toyota's dedication to carbon neutrality goes way beyond just cutting down vehicle emissions. The company is also diving deep into reducing the carbon footprint tied to how their cars are made. To make that happen, they're actively pushing for more recycling, smarter use of resources, and serious investments in renewable energy projects. That being said, there's still more work to be done to meet the bold goal of full carbon neutrality. To really understand the scale of Toyota's efforts, you need to zoom out and look at the full picture. Creating a world that's close to carbon neutral requires sweeping changes, not just in the vehicles we drive, but also in how we generate the energy that powers them. With Toyota's multi-tech strategy and their broader sustainability efforts, it's clear they're tackling these issues from all angles. And beyond just aiming for carbon neutrality, their approach delivers a host of environmental perks, maybe even more than you'd expect at first glance. But to truly appreciate what this means, let's rewind a bit and break down the benefits. As the automotive industry gradually moves toward cleaner energy, Toyota's hydrogen-powered internal combustion engines offer a really intriguing option. But how do these hydrogen engines actually stack up next to hybrid electric vehicles, HEVs, and plug-in hybrid electric vehicles, PHEVs? To figure that out, we have to ask another important question. What makes hydrogen engines stand out when it comes to environmental impact? The key difference lies in their emissions. We all know that traditional gasoline engines release large amounts of carbon dioxide, one of the biggest culprits in global warming. But Toyota's hydrogen engines, they don't emit any carbon dioxide at all while running. For anyone who thinks reaching zero carbon emissions is a pipe dream, think again. It's entirely possible, and the secret lies in how hydrogen combustion works. When hydrogen fuel is burned, it combines with the oxygen in the air to create energy. Without diving too far into the science, the reaction between hydrogen and oxygen forms H2O, which is just water vapor. That's the only thing coming out of the exhaust. As we've seen, cutting carbon dioxide emissions right at the tailpipe is a powerful way to shrink the environmental footprint of the auto industry. But do they really perform like conventional engines? Toyota has put its hydrogen engines to the test in the demanding world of motorsports. The perfect proving ground came when they introduced a hydrogen-powered vehicle into a racing series. This not only demonstrated the robustness of the technology, but also its potential to be used in high-performance applications. In these high-stress, high-demand environments, hydrogen combustion vehicles have shown they can compete toe-to-toe with traditional cars. They offer comparable speed, agility, and endurance, all of which are crucial during racing. Believe it or not, hydrogen engines are capable of delivering horsepower and torque similar to gasoline engines. These are pretty promising results, all things considered. By making key modifications to existing engine designs to accommodate hydrogen combustion, Toyota has achieved power outputs on par with traditional engines. In some cases, these outputs are even higher, a significant technical milestone. This is a testament to the potential of hydrogen as a viable alternative fuel for high-performance vehicles. However, some people have asked whether hydrogen-powered vehicles can deliver the same driving pleasure as their petrol counterparts. While this is undoubtedly the most subjective aspect of high sieves, early indications suggest that they absolutely can. Drivers who have volunteered to test Toyota's hydrogen-powered vehicles report a driving experience that is both familiar and exhilarating. These cars combine the traditional dynamics of internal combustion engines with the novelty of using a clean, sustainable fuel source. By making cars that retain the performance characteristics of conventional ICE vehicles, Toyota is effectively bridging the gap between the present and the future of automotive technology. Whether it's for daily commutes or the adrenaline rush of the racetrack, hydrogen combustion vehicles will surely deliver the performance, sensation, and enjoyment that drivers have come to love about traditional cars, all while ushering in a new era of environmentally conscious motoring. So far, we have seen that Toyota has been working on its hydrogen combustion engine, and from everything we've seen, this is an engine that is going to revolutionize the EV industry. However, they have an even crazier engine coming, and if it were to make it to the real world, it could completely disrupt the EV industry, or what's left of it after the hydrogen-powered engine. Imagine having an engine that runs on water. Yes, Toyota has been diving into the world of engine technology that runs entirely on water. This marks a significant leap in the pursuit of sustainable solutions. But before we get into the details of this initiative, let's take a minute to look at the theory behind the water-powered engine. The idea of an engine that runs on water sounds like something out of science fiction. However, Toyota has taken up the challenge of making this a reality. The core idea behind this technology is using water as a fuel source. But how exactly does the energy come from water? After all, water is one of the most stable and inert substances. It seems to have no energy at all. The key to unlocking its energy lies in the chemical makeup of water. Water, or H2O, consists of two hydrogen atoms bonded to one oxygen atom. To tap into the energy stored in water, the trick is to separate the hydrogen atoms from the oxygen atom. Luckily, there's a process for this called electrolysis. Electrolysis works by passing an electric current through water, breaking it down into hydrogen and oxygen. Hydrogen by itself is a high-energy fuel. When burned, it can produce a lot of energy, enough to power an engine if there's enough of it. In Toyota's water-powered engine, the hydrogen extracted from water would fuel a combustion process, much like a traditional gasoline engine. But unlike gasoline, burning hydrogen only produces water as a byproduct, meaning zero carbon emissions. If Toyota successfully develops this water-powered car, it would be a revolutionary change for the automotive industry. It would be a major step forward in terms of environmental sustainability. Another exciting part of Toyota's water-powered engine project is their patent filings for this technology. These patents show Toyota is serious about developing and protecting this cutting-edge technology, signaling a big commitment to making water-powered engines a reality. But how will Toyota make this work in real-world vehicles? Integrating water-powered engines into cars comes with several hurdles. One big challenge would be incorporating an efficient electrolysis system into the engine. They would also need to find safe and reliable ways to store hydrogen and design engines that can handle hydrogen combustion's unique characteristics. Despite these challenges, given Toyota's history of innovation and breakthrough technologies, they're well equipped to overcome them. Toyota has already made waves in the EV industry with their hydrogen combustion engines, so when they finally bring the water-powered engine to life, it will completely transform the game. Thanks for watching, and I'll catch you in the next one.